Hello guys. In this video, we will learn how we can implement k-means clustering from scratch in Python. We will not make use of any inbuilt ML libraries, okay, that is available in Python. So let's get started. So before we actually jump into implementation, I would like you to revise basic concepts of k-means clustering, okay. So in order to do that, I have jotted down the steps here in this notebook. So what is k-means? K-means clustering, it's an unsupervised learning category, right? So we call it as unsupervised learning. Why we call it as unsupervised learning? Because we do not have target labels. Do not have our target labels. So all we have is x, there is no y, right? There is no y. So what is this x? These are the data points with some features f1, f2, f3 up to n features. Okay. So all we have is this, and we have to cluster these data points into multiple clusters. So similar data points will be grouped together and those will be called as belonging to some cluster. Okay. So this is what k-means clustering is all about. So what are the steps in k-means clustering? So it's simple, right? So once we have the data with us, we will first select random number of clusters and we call it as k. Okay. So we call the random number of clusters k. We have to pick the number of clusters that we want to have in the given data set. Then what we have to do? We have to randomly pick k cluster centroids. So what is this k? These are the number of clusters we want to have the data grouped into. So once we have picked the random cluster centroids, and how do we pick it? So we pick it within the data points that we have with us. So one of them or k of them will be chosen as the cluster centroids. Then the third step will be to assign the centroids to the data points based on the Euclidean distance. So what this step does? So for each data point, we will calculate the distance between the centroids, the chosen number of centroids, and whichever gives the least distance, we will assign that particular data point to the least distant centroid. Okay. So if the distance between the centroid and the data point is minimum, we will assign that data point to that particular centroid. Okay. So this is our third step. Then what we do? We move the centroids. How do we do this? We take the average of the data points assigned, to each centroids in third step, and then the new centroids will be the average. Okay. So this is our fourth step, that is moving the centroids. Then what we do? We calculate the cost function. So how do we calculate it? We calculate the distance between the data points and the centroids that those data points are assigned to, square them and then divide it by the total number of data points, and we sum it over all the data points. This is called as distortion cost function. Distortion cost function. Okay. And we repeat these steps for multiple times. So all these steps I have explained in detail in my k-means clustering video theoretically. So if you guys have not watched that, please go back and watch it and then come to this implementation part. Okay. So now with implementation, what we will do? We will repeat steps 2, 3, 4, 5 multiple times, right? So this second step, randomly pick k cluster centroids, we will run this, let's say around 5 or 10 times. Each time we will run these assign centroids, move centroids, and then calculate cost for multiple number of iterations. Okay. So we will have basically 2 loops. So first loop will be to randomly pick k centroids, random k centroids, and within this we will run steps 3, 4, 5 for multiple iterations. Okay. So this is how we are going to structure our k-means clustering implementation. Okay. So without wasting much time on theory, let's get started with the implementation. Okay. So here I have imported the required library, and then I have read the data set also. So I will give the data set also in the video's description, so you can download it. So what we have done, I have used gen from text method from NumPy and then read the data set. Okay. So this is how my data looks like. So totally I have 10,000 records. Each data point has 6 features in it. Okay, and this will be my X. There is no Y. There is no label. So that's why this will come under unsupervised learning. Okay. So now just to run some basic checks, let me check the maximum feature value and minimum feature value in this whole data numpy array. So how do we do that? np.max of data. Okay, so the max value is 12. np.max of np.min of data. So it is minus 12.39. Okay, so this is how our data is distributed. So you can take this as a range. Okay, so this is our range. So if we check the mean, so it is 2.20. Okay, so this is how we get the range of any data that we have in a numpy array. So why I did this, you will see in a while. Okay, now let us define some functions which are required for us to implement this k-means clustering from scratch. So the first thing would be, we need to define a function which will calculate the Euclidean distance, right? So let me call it as calculate distances, and the input will be training instances and then query instance. Okay, so for each query instance we will calculate the distance between that query instance to all the training instances. Okay, so this will be the input for calculating the distance. And what distance metric we are using? We are using Euclidean distance. So this is how you implement and return the Euclidean distance. So this is np.sqrt, np.sum, np.square. So if you are wondering what all this, please go back to my video where I have explained different distance metrics and how do we calculate them. Okay, so I will not waste time in explaining again how do we calculate the distance metric. It will, otherwise this video will become long. Okay, so once I have np.square, I will get the difference between query instance and my training instances. So training instances, and I want it to be summed across axis is equal to 1. Okay, so this is how we calculate the Euclidean distance. Okay, now we will go step by step with this particular algorithm. So we need to first initialize k number of centroids, right? So that's what we are going to do now. So for that we will define a function called as define generate centroids. So what will be the input? Input will be training instances and k. What is k? K will be the number of centroids that we want to have. So this will be an integer. Okay, then what we will do? We will randomly pick the centroids, k cluster centroids. How do we do that? So let me say indices is equal to random dot sample. Have I imported random? Okay, I have imported random. Okay, so random dot sample from range of length of training instances, and how many I need to pick? K. So the parameter for random sample will be k, and we are picking k number of indices. I will tell you what it does in a minute. So then I will say centroids is equal to training instances of indices. Then I will return the centroids. So this method is actually self-explanatory. So nonetheless, I will explain it to you guys. So what it does, from the training instances that we have with us, so here from the training instances, I will ask this function to pick k random training instances as my cluster centroids. So how do I do that? So I have 10,000 data points with me, right? So out of those 10,000 data points, I want to pick some random k data points as my centroids. So how do I do that? First, I will take the indices of that particular data point. So this indices will hold k number of indices between the range 0 and 10,000, that is 9999. Okay, so this will be the indices. So if I say k is equal to 3, so this indices will be 3. It will be a numpire of 3 numbers. So it can be 2, 5, 100. So initially it can look like this, some random indices. So what is this 2, 5, 100? So second training instance, 5th training instance and 100th training instance will be our cluster centroids if we choose k is equal to 3. Okay, so that's why I am doing the second line, centroids is equal to training instances of indices, and then I am returning those training data points as my cluster centroids. So hope this function is clear to you guys, how it works. Then what I will say, once I generated the centroids, once I have created or randomly selected the cluster centroids, I need to assign the centroids to data points. So for that, I will create another function. I will say assign centroids. So input will be training instances and then centroids chosen randomly at my first step. So these two will be my input. Then I will say centroid indices is equal to, it will be a list. Then what I will do, I will loop over entire training instances. Okay, so for data in training instances, so what I will say, I will append the data points to each centroid. So centroid indices dot append. So what it will be np.argmin calculate distances centroids comma data. So I will explain it to you what this function is doing. Okay, then return np.array centroid indices. So in the end, I am converting this list into numpy array and then returning it from this particular function. So let me tell you what I am doing here. What I will do, for each training data in my training set, that is for each data in 10,000 records, okay, what I will do, I will calculate the distance between the centroids and that particular data point. Okay, and then take the minimum of that. So this np.argmin will return me the index of the minimum distance. So what I will say, for each data point, I will calculate the distance between the centroids. So this will have 10,000 distances for each centroids, right? So if I select K3, so for all the 10,000 data points, it will have the Euclidean distance between those data points and all the 3 centroids. And out of that, I want the minimum distance centroids to assign that data point to that particular centroid. Correct? So for that, I am doing np.argmin calculate distances between centroids and that particular data point. And then I am appending that centroid index as my centroid index for this particular data point. Okay, so this is what this particular function is doing. And then finally, I am returning the np.array, returning the centroid indices for each data point as a numpy array. Okay, hope this method is clear to you guys. Then what I will do, once I have assigned the centroids, I will need to move the centroids to the average of the data points assigned to that. So let me create another method and call it as move centroids. So the input to this function will be training instances. I will need the centroid indices, so which will be returned from assigned centroids, centroid indices, and then the centroids itself, because I have to reset those centroids, right? So that will be my new centroids. So what I will do, so what this function does, it actually accepts the training data, the centroid indices obtained from assigned centroid method, okay, and then the centroids, okay. Then it will return the new centroids which are equal to the mean value of the data points assigned to the respective centroids. Okay, so listen to me carefully and please concentrate while I am typing the code. Okay, so now let us type it. So we are actually moving the centroids now. So new centroids will be equal to training instances of centroid indices of equal to I. I'll tell you what this does. Okay, dot mean axis is equal to 0 for I in range of length of centroids. Okay, then it will be return np dot array new centroids. Okay, so this is how I designed my move centroids method. So for you guys to understand it, you need to know what this move centroid does. So let me explain to you guys. Let me quickly refresh it to you. Okay, so let's say after initializing the centroids and assigning the data points to the nearest centroids, let's say this is our centroid and let's say these are our data points which have got assigned to this centroid C1, and we have another centroid C2, and these are the data points assigned to this particular centroid C2. So now what I am doing, these are my data points, right? So what I'll do, I have to move this centroid. So what I'll do, I will take the average of all the data points assigned to centroid C1. I will add them up and then I'll take the average. So that will be my new C1. And similarly for C2, I will sum up the data points assigned to that particular centroid C2 and then take the average. That will be my new C2. Okay, so that's what I am doing here in my move centroids step. Okay, I am taking the mean. Okay, hope it is clear. Once we are done with this move centroid step, we will have to compute the cost. So for that, let me define a function. Define calculate cost. So what will be the inputs to this? Training instances. I need the centroid indices and the actual centroids in order to calculate the cost. Do I really need centroids? I do not think we need centroids. Okay, so first let me just write the cost, then we'll get to know whether we need centroids or not. Okay, so what's the cost? I have given the formula here, right? So we have to implement this. It's just this, we have to implement it in Python. So it's simple. So cost is equal to np.mean, np.sum, np.square of centroids of centroid. Wait, let me just think over it. Do we need centroids? So yes, we need centroids. Okay, so centroids of centroid indices minus training instances, and this should be along columns. Axis is equal to 1. Okay, then I'll just say return cost. So now we have our cost function. So this is our distortion cost function. Let me just comment that out here. Distortion cost function. Okay, so now if you can relate this formula to what I have it here. Okay, so this is my formula, what I have just implemented it. Okay, so centroid indices for each data point minus that particular data point, taking the square and summing over entire data set and taking the mean of that. So this will be my cost. Okay, so that's what I have implemented it here. So now I have written all the required methods to implement our k-means. We will define another function which will do all these steps multiple times, and when I say all these steps, it is generating the centroids for multiple times, and for each generation of centroids we will run assign centroids, move centroids, calculate cost for multiple iterations. Okay, so why we are doing this multiple times? In order to have the correct random initialization of the centroids initially, and then arrive at the correct cost and correct centroids, and hence correct cost. And we will do this for multiple values of k, how many cluster centroids we want. Okay, so that's what I'm going to do now. So it will be, let me call it as define, let me call it as restart k means. Does that make sense? Okay, it makes sense because we are randomly initializing the centroids again each time, right? So it makes sense to call it as restart k means. So what will be the input? It will be training instances, number of centroids, so number of iterations we want to run for each initialization, and how many times we want to restart it. So let me call it as number of restarts is equal to 10. Okay, now, so what I need to store the cost at each restart, right? So let's say for the first time I randomly initialize the cluster centroids, I did all these things, and then I will store that cost. For the second restart, I will run these steps for 10 iterations. Okay, then I will compare the previous cost with the latest cost. If the latest cost is less than the previous cost, I will replace the best cost, okay, with the latest cost. So that's what I have to do now. So for that, let me initially create a best cost variable, and let me just assign it a infinite value. So this is how we assign infinite value to any variable, and here the variable name is best cost. Okay, so now what? So it's simple. For restart, let me say restart index in range of number of restarts. Okay, so I have to restart, and when I say restart, I have to try multiple random initializations, and within multiple random initializations, within each random initialization, I have to run my k-means clustering algorithm for so many number of iterations. So here I have fixed it at 10, but you can choose higher number of iterations depending upon your needs. Okay, so now let me write it. So for each restart, for each random initialization, I need to randomly generate the centroids, right? So I will just need to call that now. So we have all the methods defined here. So I need to call generate centroids, and it returns the centroids, right? So centroids is equal to generate centroids training instances, comma, number of centroids. So how many centroids I want, I need to pass that parameter. Okay, so we will try this for multiple values of k. So this is our k, basically number of centroids is our k value. So we will try this starting from 1 2 3 4 5 6. Okay, let's say we will try for 6 or 7 cluster centroids. Okay, so we'll see how it goes. Then what I'll do, for each of these random initializations, I need to run for these many number of iterations. Okay, so for iteration in range of number of iterations, so what I'll have to do, I will have to say assign centroids. I'll have to call this, and then I have to call move centroids. So we have to repeat these two steps for multiple iterations, and then once we are done with all the iterations, so let's say in this case 10 iterations, we will have to compute the cost. So there is no need to compute the cost at each iteration. So it is enough to compute the cost at the end of all iterations. Okay, so cost is equal to calculate cost. So these are all the things that we have to do. Okay, now we will supply in the required parameters here. So assign centroids, it will take training instances and centroids. So we will just copy and paste them here. So assign centroids, Okay, then move centroids. So it will take 3 parameters, right? So the centroids and then training instances, centroid indices. And this centroid indices will be returned from this particular method assign centroids. So I'll have to store that in a variable. Centroid indices is equal to, and this move centroids will return me a new centroids, right? So I will just replace the centroids here. Centroids. Okay. So what this function is doing, initially randomly generating the cluster centroids. With those cluster centroids, I am running k-means clustering algorithm for 10 iterations and then arriving at my final centroids. And once I have run this for 10 iterations, I will calculate the cost. So in order to calculate the cost, what all things I have to pass? I'll have to pass training instances, centroid indices and centroids. Okay, so this is how I calculate the cost. Now I told you something about the best cost, right? So what is that best cost? We have to give that logic there, right? So now I have the cost, and this cost is for first random initialization of k centroids, right? So I have to check this cost with my initialized best cost value. So what I will say, if cost is less than best cost, I will replace my best cost with cost. Okay, and also I will say those will be my best centroids, right? So these will be my best centroids if the cost is less than my previous cost. So I will have something called as best centroids is equal to centroids. I'll say centroids dot copy. Then what I'll do, I will return. Okay, so return, what I'll return? I'll return best cost and best centroids, right? So why we need this best centroids return? In order to have our predictions in place. So these will be our best centroids. For any unseen data, we will make use of these centroids to create these many number of clusters. So whatever parameters we decide, for those many number of clusters, we will make use of these best centroids. Okay. So this is our actual k-means algorithm function. So I have done this now. Then what I'll do, I will create a list to test out for different number of clusters. So I'll say number of clusters is equal to, so let me try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since I have 10,000 data points, let me try for different number of clusters starting from 1 cluster all the way through 10 clusters. Okay, you can increase it if you would like to. Okay, so we will see how it performs now. Then for each of the clusters, I need the cost. So it will be a list. Costs is a list. Then if I need to time it, let me time it, how much time it takes. Okay, start time is equal to time dot process time. So I'm just making use of time module in Python to compute the time. So I'll read the data. I have already read it here, right? So I will have everything in one place. I'll just copy it. Okay, so this is my data. Then for k in number of clusters. So these are my different values of k, which will be passed as number of centroids parameter to this particular method restart k-means. Okay, so what I'll be getting, best cost and best centroids, right? So it will be cost comma, sorry for the caps, cost comma centroid is equal to restart k-means, and what all things it takes, training instances, here it's data, number of centroids, that will be k, correct? And then these are the default values. Let's leave it as it is. So we'll not pass anything. So it will take 10. If you want to override this, you can send in 5 restarts and of 10 iterations or 100 iterations, it's up to your choice. Okay, so just let me try with 10 restarts, and each restart will have 10 iterations. Okay, so that's what it is. Then what I'll say, for each of the clusters, if for cluster 1, cluster 2, cluster 3 up to cluster 10, I will save the cost in this costs list. So what I will do, I will say costs dot append this cost, and then I will just print the cost at for each number of clusters that we get it. Okay, so what I'll say, print, I'll just display the, how should I display it, let me think. So okay, it will be good to display the number of clusters and then the cost side by side. Okay, so I'll say uh, k is equal to comma cost is equal to, so I'll use the format option, format, I'll print k comma cost. Okay, so these are my costs for each k in number of clusters list. Okay, so now to run entire process for 10 clusters, till 10 clusters, I will compute the time, and time is equal to time dot process time, and I can say print total time taken. It will be in seconds. Okay, dot format, it will be end time minus start time. Okay, so that's it. So if I hit it, it should start executing. Let's see if we get any errors. I think we are good with all the methods. Let me see. Okay, so I'm not seeing any error right now. So right now it is running for k is equal to 1. Okay, so it will go here, k is equal to 1, and then it will do all these things for 10 iterations. Okay, so for k1 the cost is 128. This is the value of distortion cost function for one cluster. For two clusters it is 40. So it may take a while, it may take a minute to complete all these 10 clusters, to compute the cost for all these 10 clusters. Okay, so for 3 clusters the cost happens to be 18. So there is a drastic reduction from 128 to 40, 40 to 18. Let's see how long we see the reduction here. Okay, so we should be having the cost for 4 now. Okay, so there's a drastic reduction, 18 to 2. Okay, but still I see these as high values. The cost should not be this much high, provided the data is within the range of -12 and +12. So we'll see. So k is equal to 5, cost is 2.8. Okay, now it's started to saddle out here. Okay, so we'll see. So I'll pause this recording for a while till we finish for all k is equal to 10. Okay, then I'll come back. Okay, so it has completed the process, and it took around 80 seconds to try out for all the clusters ranging from 1 cluster through 10 clusters and iterating 10 times. And from the initial cost of 128.18, we were able to come down to 2.48. So I made a mistake here of not setting up a random seed. So if you run this code, you may not see the exact results here. So in order to have the reproducible results, what we can do is, initially here we can set the random seed. Okay, so random dot seed, I can just say some value 43. So now if I run it again, let me run it again and then check the values, so that if you run this code with the same random seed 43, you should be able to see the same values as I see here. Okay, so what I'll do, I'll run it here again, and then I'll come back once this execution is complete. Okay guys, so it has now completed for all the 10 clusters, and in between we are seeing some runtime warning, invalid value encountered in true divide. So for now we will ignore this, and I think most probably it is occurring at either of these two steps. Okay, So either in move centroids or while calculating the cost. Okay, so we will not bother about this error because the goal of this video is to understand how we can implement k-means clustering from scratch in Python without making use of any inbuilt libraries. Okay, so now that we have already got the results, but somehow I feel these numbers are bit high. So what we'll do, since we know the range of our data, ranging from -12 to +12, what we'll do, we will do the scaling. Okay, we will normalize the data to have the values between 0 and 1. So all these values in this data will be normalized to have the values in the range of 0 and 1. So for that we will make use of something called as min-max scaling, and we will not use any library for that. Again, we will implement that also in Python. Okay, so we'll see after scaling how this cost looks like. Okay, then let me do one thing. I'll just copy this. Okay, I'll just copy this entire thing. Once I read the data, I'll have to make the change here. So it will be data is equal to data minus data dot min, and I have to do it for each training instance, each training data. So we have 10,000 records, so I have to traverse through the rows. So access will be equal to 0. Okay, so this divided by data dot max of access is equal to 0 minus data dot min of access is equal to 0. So this is basically a min-max scaling formula. So if you are not comfortable with this formula writing here by your own, you can make use of min-max scaler available within sklearn library. Okay, so since I told you I will not use sklearn library for anything, so I am not using that. So now I have the data here. I can try to run this now. Let's see. So we will come back once it is done. So I'll pause the video for a while. Okay, so it is complete now. So as you can see, after squeezing the data in the range of 0 and 1, we can see there is a significant reduction in the cost. So why this is the case, let me explain it to you. So while we calculate the Euclidean distance, right? So where is that calculate distance? Right here. So what happens, we actually take the difference between the two data points and then square them up. So if any feature is having higher value, this will have greater impact on the distance because of this particular square thing here, and that particular feature will have more impact on the cost. So why it will have more impact on the cost? Because it's again depending upon the training instance and the centroids that we have. So if the features are having high value, again it is getting squared here. So the higher valued features will always impact on the value of the cost that we get. So it is always advisable to scale the data between 0 and 1 in order to have the correct convergence for any machine learning algorithm per se. Okay, so this is how we should be implementing it. And one final thing what I want to do is let me visualize how the cost is getting reduced. Okay, so what I'll do, I will define another function called as visualize. It will take number of clusters comma costs at each cluster. So if we have chosen cluster is equal to 1, what's the cost? If we have chosen cluster is equal to 2, what's the cost? 3, what's the cost? So on and so forth up to 10 clusters we are calculating, right? So let's just plot how the cost is getting converged. So all we have to do is we have to plot plt.plot number of clusters comma costs, and we will just give some title to it, plt.title. So what we can say, it will be cost versus number of clusters or you can say number of centroids, any word you can use. Then it will be plt.x label. The x-axis label would be we are plotting number of clusters on x, number of clusters k, right? So I have to put it in within quotes, otherwise I will see the error. Okay, and then I need a y label. Y label will be it will be cost, and which cost it is? It is distortion cost, right? So distortion cost. And let me just give some cosmetic to it. So plt.grid, let me set the grid to true so that we'll have the boxes displayed over there. Then what I'll say, I will call this visualize number of clusters comma costs, right? So what's the variable name? Costs, right? So I'll just pass it here. Okay, so now what we have on x-axis, we have the number of clusters, and on y-axis we have the distortion cost. So as you can see, we are seeing the considerable reduction from cluster number 1 to 2, 2 to 3, 3 to 4, and from 4 onwards it's getting plateaued here, right? So it is getting flat. So when I say it is getting flat, the gradient is almost 0 there, right? So this particular part here the slope is almost 0. So what it states, we can either choose 5 or 4 as our number of clusters. Okay, so this is actually called as elbow method in for choosing the number of clusters that we want to have. I'll just write it down here. So this is called as elbow method. Okay, so why this is called as elbow method? So if you take a look at this plotted diagram here, so this here is our elbow. So it just resembles the shape of our hand folded at particular angle, and this particular junction here represents the elbow. It just looks like this elbow, that's why it is called as elbow method. So there is no significant reasoning behind calling it as elbow method. Okay, so that's it for this implementation. And for this particular example, the optimum number of k would be either 4 or 5. So even you can see from this particular costs here, right? So after 4, there is no considerable reduction in the cost. So you can either stop it at cluster 4 or you can go with 5 clusters. Okay, so hope you guys enjoyed it. I know there is a lot of np.mean, np.square, np.sum and all those stuffs involved. But if you have seen my k-means clustering algorithm video, it will be much easier for you guys to understand it. So please give it a time and go over it again and again, watch it slowly so that you will understand each and every line of this code. I will give the link of this notebook in the description, or I will pin it in the comment section, so you can have a look at it and learn to code it yourself. And if you find any improvements you can do, just let me know and let everyone know. You can announce it in the comment section. Okay, so that's it for this video, guys. If you haven't subscribed to my channel, please do subscribe. And if you are liking my content, please give it a thumbs up so that it will reach the wider audience, and also it will help my channel to grow. Okay, and that's it. Till we see you in the next video. Happy learning. Bye bye.